Awesome. So welcome to our session. This is our day 14, if I'm not wrong. And today we're basically going to talk about fungible token. So we're going to walk through a fungible token smart contract and see how this is going to be done in this particular session. So here are the tools. I really hope we have all these in place already. So we're basically going to walk through a fungible token smart contract today. And from there, we'll be able to see how everything is going to unveil. So I'll just switch on to the code right away. So here we are. And again, maybe before, if I can just take us back a bit right here. And if I can Google something. Okay, thank you. So if you just Google near examples, then you click on examples.near.org. So these are some of the demo projects that have been availed to you guys, something that you can use as a guide to coming up with your own. So right here, there's a fungible token. There's a fungible token project over here. So you can just click on browse on GitHub or open in Gitpod if you're planning to work on this online. So this is a project you're actually going to walk through, but then you're going to modify it as we walk through it, just to see how things are going to unveil. So this is an example of a fungible token smart contract. It's a Rust project. So this is what I basically cloned, and that is what we're going to walk through right in our code over here today. So there's a source folder. I just opened the contract. I just opened the contract folder. So I left the scripts, the test, whatever, all these folders. So just click on the FT and the source. And this is the file you're going to work from. So again, let me, oh, sorry. Oh God, what have I done? Yeah, so you are here. If maybe you guys can just confirm if you can see my VS Code.
Yes.
Okay, thank you. So right here, like I said, you guys are already familiar with all these. Now there's a script folder right there. You already know what's inside there. That is basically going to help us interact or do some very quick commands within our smart contract. Then this is the file you're going to work from. So it is the simple or a a fungible token smart contract you can come up with. Now all these are tests. So this file is up to line 99. So it's actually short because most of the things have already been done for you by the near contract standards. I just showed you that that module in our session. Yes. So okay, there are some errors within my file. So I guess I may need to do some cargo update over here. So let me just run that and see if they'll go away. There are some things we are pulling from the near contract module, or near contract standards library. Okay, so you realize you're really going to make a good use of it over there. Then the rest of these other modules, we should be familiar with them up to now because we've used this before. Now, the very first standard we talked about yesterday was fungible token standard, right? So that is basically what we're going to look at. So I've just put my cursor on the fungible token. So the keyword, the word fungible token, and I'm going to press F12 on my keyboard. So this is basically going to open the source code of this particular module that we just imported. So that is exactly what I did. And on doing that, let's hope this We can minimize it as, yeah. So in my fungible token, it's actually a structure. So the fungible token structure has some instance variables that we're really going to look at. So we have the accounts. Accounts is basically going to be a lookup data structure that is going to hold the account ID. So in this case, the wallet addresses and the balance that is against that wallet address. Then you're going to have the total supply of the fungible token. Okay. Then the account storage usage, this is basically going to come in handy while we talk about storage staking. Again, I think I addressed that in our previous sessions. Then the fungible token structure is implemented right here. So there are some methods over here. We have the new method that is basically used to bootstrap everything. So we have the accounts given some prefix over there. Total supply 0, account usage storage is also given the value 0. So this is basically helping us, create an object, a fungible token object. Then right here we have these other methods. Now, you guys are going to read through these. Maybe let me just share that link with us. The fungible token smart contract that has been availed as that we can work from, help us bootstrap everything. So I've just put that in the chat. I really hope you can find that in the chat. So, okay, if you can go back over here. So that should be, you should find time and just go through these methods. These are helper methods. Basically, the methods that are going to help us achieve what we need to do within the methods we looked at yesterday. So the transfer call, the total supply, and all that. So within those methods, we have some other internal methods that are basically doing the actual transfer of tokens from one account to the other. Okay. So like the measure account storage usage, that is basically used for storage staking. And I really hope we know up to now what that really achieves. Then internal unwrap balance of. So this is basically going to check balance of the given account ID. So first of all, it is going to access the accounts object. So like I said, this is going to be a look map object. And it is going to take the account ID. If it gets the account ID, then it will basically return the balance that is against that account ID. So that is basically what's happening there. If nothing was found, then it will panic with this string. The account, specifying the account is not registered. Then we have the internal deposit method. And again, we're going to see where these methods are going to be used as we proceed. So don't be worried, really, as per now. So internal deposit, this is where an account wants to make a deposit of some amount against a particular wallet address. Now, right here, we have self internal and wrap balance of. So again, this is going to get the balance of this particular account ID. It will be stored in the balance variable. And then right here, we are checking the balance, or we're taking the balance. Then we are adding the specified amount. In this case, cautiously again, using the checked add, so that if there's overflow, it is going to be well handled. So we do the addition, and our new balance is captured over there. Then we simply we update that record in our data structure. So self.account.insert the new balance against the account ID. And that is also going to affect the total supply of the tokens because you've actually deposited something to your account. So we also need to update the total supply of tokens within this particular fungible token smart contract. And to do that, we're simply going to access our total supply instance variable as a mutable object. Then we again going to cautiously add this amount to it. So if all goes well, that should be updated in the state. And if something went wrong, then we're basically going to panic with this string, total supply overflow. Okay. Yeah, so that is basically what the internal deposit does. So we also have this other method right here, internal withdrawal method. So this is going to transfer tokens from the stated account ID to another account ID. So in this case, whoever is signing this transaction is the account of the wallet address where the tokens are going to be taken from or withdrawn from. So right here we have the internal and wrap balance of again going to get us the balance of these account ID. In this case, the wallet we just specified over there. Then we get the balance, we update by, in this case, subtracting the specified amount from the balance. Then we get our new balance. And again, we just need to reflect that back to our database. Okay, so that is how we go about that. Then you realize up here, we added something to the amount, actually, to the total supply. Now, when we withdraw, in this case, we have to burn some tokens to the total supply, okay? So that's why right here, we subtract again cautiously. So we do the subtraction of the specified amount. And if there's anything or any error going to take place, we panic with that string. Awesome. We have, so take key note of these two methods, guys, the internal withdraw and internal deposit for the upcoming illustrations. So right here we have internal transfer, basically transferring from one account to the other. So we specify the sender ID and the receiver ID and the amount that is going to be transacted with an optional string, in this case, the memo, okay? So we're going to require, right here, we're going to require that the sender ID is not equal to the receiver ID. In this case, the sender and the receiver should be different, okay? Then we also need to verify that the amount is actually greater than 0, so that we're actually going to do some actual transactions. Then the very first thing we're going to do, because we are transferring from one wallet address to the other, is we first of all going to withdraw from the sender ID, the specified amount. Then after withdrawing, we deposit that amount to the receiver account ID, okay? Then after that, there's this event listener right here, or event you're going to emit, that is the fungible token transfer. So this is basically going to be an event that you can as well listen to, specifying the old owner, in this case, the sender, and the new owner, the receiver, and the amount that was transacted, and the optional string. Then we basically emit it like that. Then right here, we have internal register account. Like again, I said yesterday, guys, in our session yesterday, that before you can make any transaction within a fungible token smart contract, then you ought to have staked some near tokens for storage purposes against your account details. So that is basically what this method is going to help us achieve. Over here, again, we'll see how that is coming into play. Then we are implementing, yes, someone has a question. Isaac?
Yes, when you say that one needs to have staked some near tokens against the account.
Yeah.
So you mean if I have, say, 100 near, I need to have staked it?
No. Oh, okay. What I mean is, you see the figures of your balance, or the figure of money that is going to be stored within the smart contract is going to occupy some space, right?
Yeah.
Then there's a maximum figure that, according to the design of the fungible smart contract, one can, I mean, the maximum amount one can have within an account. So that is usually known by whoever is doing the smart contract. So what you usually do is you stake for the storage of that information. And maybe if I can just show us this again. So you see right here in the account object, the lookup map that is storing the account ID, sorry, the balance against the account ID. So this is the information for you to store your wallet address. In this case, it could be Isaac.testnet has this number of NIA tokens. So that information, for it to be stored on blockchain, you have to stake some NIA tokens to cover for that space that information is going to cover. But you don't have to pay for it every time you do the transaction on blockchain, because once you register, in this case, once you create an account, then you just make the payment once. Then if you are going to deregister or, you know, you're going to unregister from the platform, then the amount you staked will be credited back to your wallet. I don't know if you get it now.
Okay, so basically you mean that a certain threshold has to be met, as specified by the owner of the smart contract, and has nothing to do with like staking pools.
Sorry?
Okay, you mean that a certain threshold has to be met.
Threshold, what do you mean by threshold?
Like you need to have some certain amount of tokens in order to.
No, okay. The thing is, you have to pay some tokens to cater for the storage of your account's information. So it could be something as small as 0.002 NIA, just to cater for the storage of that particular information. And you do it once. You just do it once for the lifetime of your account in that smart contract. I don't know if you get it now.
Yeah, I get it. Thanks.
Okay, great. So maybe if you can just take us back to, I think, where were we? Internal register. Yeah, I think I talked about that. We were right here. So we are going to implement a fungible token call. Again, this is a trait. And let's see if we can have a look at it. Okay, it should have been defined somewhere. Can't seem to find it here, but this is a trait that we're basically going to implement. So this trait has some methods, the methods that we actually talked about yesterday. Transfer, FT transfer call, total supply. So that is basically what is going to be implemented right here. So the very first method is fungible token transfer. So this is going to transfer tokens from the sender's account ID to the receiver's account ID. So the method expects you to specify the receiver's account ID and the amount you want to transfer to the receiver's account ID. Then there's an optional string over here. It's called memo. So this is going to be a payable function. So by payable function, I mean whoever is going to call this method must attach some NIA tokens or has to attach one Yocto NIA while calling this particular function, as you can see in line 160. So the very first thing it's checking is if one Yocto NIA, and only one Yocto NIA in this case, was attached. Okay, so that is what is being confirmed in line 60 before anything can be processed. Then the second thing, we are getting the sender ID, and the sender ID is the wallet address that is signing this particular transaction. And that is how we get it, what I've just highlighted. Then the other thing we'll be doing is getting the amount, in this case, the balance. So the amount is provided as a U, capital U, 128. Again, this is a NIA trick, basically getting a figure as a string, then converting it into an integer, the relevant integer, using the into method. So that should not confuse us. So at that point, we're getting the amount. Then we are making use of the internal transfer method we just saw right here, which expects the sender ID. In this case, whoever is signing this transaction and the receiver ID is specified over there, the amount to be transacted, and the optional string memo. So basically, as you can see it over here, guys. Okay, so that's basically it. Then a fungible token transfer call method also requires the receiver, the amount, the memo, and a message. Okay, so that's the added parameter to that call. And like I said yesterday, a fungible transfer call is going to transfer near tokens or tokens to a wallet address that is owned by a smart contract, or a wallet address where a smart contract has been deployed to. And so it is called FT transfer call because it's going to make a cross contract call. Okay. So this again is a payable transaction. So you have to attach one Yocton here. Then it is required that the prepaid gas, in this case, the gas that you attached to this call, should be greater than the gas for fungible token transfer call. Again, the gas for fungible token transfer call should be defined somewhere. I'm just trying to get that over here, right there. So that is how we've defined the gas. Then if I can get down here, where was I? Yeah, over here. So if that is true, well and good. If it's not, then more gas is required. So it will panic with that string and the transaction will be rolled back. So if everything goes as expected, then we'll get the sender's ID, in this case, whoever is signing this transaction, the amount that is being transacted, then the internal transfer, in this case, from the sender ID, whoever is signing the transaction, and the receiver ID, in this case, the smart contract's wallet address, the amount and the memo option or string attached. Then this method is going to invoke a cross-contract call. That is basically what is happening here, guys. I don't know if this is captured somewhere. Fungible token receiver. So this is coming in as a module. If you can remember what we talked about during the cross-contract call, right here. So this contract is going to be is expected to have implemented okay, I don't think it's that. Should be this, yeah. This one. It's expected to have implemented this method FT on transfer. And it is going to expect a sender ID, the amount, and the optional, and the message string, okay? So using this module that is going to be generated while this source code is going to be compiled down, that is basically what we are using down here to make the cross contract call on FT on transfer method, giving in the parameters, in this case, the sender ID, the amount, the message, the receiver. So the receiver ID is actually the wallet address where the receiving smart contract is deployed, okay? So again, this receiver ID is not just a contract or any other, it's not just a wallet address or the normal wallet address we own. In this case, this wallet address is expected to have a smart contract deployed in it. So that is what we specify over there. Then we give the deposit, attach some deposit if required. Then we give it its gas or the gas it needs to make this transaction. Then we're basically going to listen for some some response using this .then method. And for us to be able to handle the response that is going to be returned back from that method on that other smart contract, then we have this method in place, FT resolve transfer. And again, this is going to be a method that is going to be implemented within our smart contract to handle the response from the cross-contract call that we made earlier. So this method, it should also be somewhere. Let me just do a very quick search. So yeah, this method is also coming in as a trait. So again, we'll have to implement this within our structure. That is, it's going to accept the send ID, the receive ID, and an amount. Okay, so let's just have a look how this is implemented here. So again, we are passing in the sender ID. So don't forget, guys, the send ID is whoever is signing this transaction. Okay, then the receive ID is the whoever is receiving the tokens. In this case, the wallet address of a smart contract. That is the receive ID. The amount right there. Then we have, so in this case, this method is expected to live within this smart contract. And that's why we are passing in our current account ID. So current account ID method of the ENV module is going to return the wallet address where we are going to deploy this fungible token smart contract into. Then we specify the deposit, if any is required, and the gas that is required to resolve, basically to make this transaction by invoking that method. So that is basically what is happening there. Then we have this other function, FT total supply. So this is basically returning the total supply of the tokens. Okay. Then FT balance off is checking, given a wallet address or given an account ID, it is going to resolve with the balance against that wallet address. And if none is found, then it will basically return 0. Again, that is basically what's happening over there. So again, to our fungible token, we're going to implement the internal FT resolve function. So that is basically the function I talked about over there, our callback function. And like I said, it is going to accept the sender, receiver, and the amount. So those are some of the parameters we're going to attach to it. However, you realize that whatever parameters or arguments we provided here is more than what has been specified over here. Okay. So like I said, again, this is a callback. There is a callback function that is going to be used in the cross contract or within our promises. So these other parameters, the last 3 parameters, comes in by default. Okay. So those ones are going to come in as added parameters by default. So again, right here, the amount is going to be the amount that was specified. Then we're going to check if there's any unused amount, and we do that by matching. So in this case, we're basically getting the response from the FT on transfer call or from our cross contract call. Okay, so that is basically what we are trying to check here. So we get the value using the successful this promise result enum, and invoking this method successful, this will give us a value. So this value is what the other, so in this case, the external smart contract responded with. Okay. So we're going to convert this value. So again, this is how we do the conversion. We're going to convert it to IU 128 value. Then over here, if everything is okay, we're going to get the unused value, right? Now, right here, we're basically going to check if the unused value, okay, we're going to compare the amount, in this case, the actual amount that was specified to be transferred, and the unused amount, and we're going to get the minimum. Okay, so this is basically getting the minimum given two values. So it will basically respond with the minimum amount if the unused amount was actually got. If it wasn't, then we're going to resolve or return the amount that was captured before. And if everything failed, we'll again just resolve with the amount. And if the unused amount is greater than 0, so right here we are getting the unused amount. And here we are checking if it is greater than 0. In that case, we need to refund back or credit back that amount to the sender because it was not used. Okay, so we first of all get the receiver balance by invoking that. So if the receiver balance is greater than 0, then we're going to do a refund. So we again get the minimum of the receiver balance and the unused balance. Then we update the receiver's balance by taking the receiver's balance, subtracting the refund amount. So don't forget, guys, refund amount is the value we're going to get after checking the minimum value between the receiver balance and the unused amount balance. Okay. So in this case, actually, we expect the receiver balance to be greater, or to be greater than the unused amount, if any. So that is basically what is going to happen over there. And after making the refund or making that update back into the database, then right here, we're going to access the account of the sender and credit this amount back to their account now, the unused or the excess amount. So that is basically what we're going to do over here. Self.accounts.insert sender's balance. So we just got the sender's balance over there, plus the refund amount. So that is the update we're going to make. Then we emit this event, the transfer event. Then you basically return with the amount. So this is the amount that was being transacted minus the refunded amount. So that will give the actual amount that was used. So if the sender was not found, in this case, this sender address never existed within the database. Okay. So how do we handle that? It means that some tokens are going to be banned. And again, guys, I know we've come across this concept, tokens being minted, tokens being banned, and maybe some of us don't know what really the statements mean. Now, like in this scenario, we're going to ban this token because, okay, right here, we should be refunding this or crediting this refund amount to a particular wallet address. However, this wallet address does not exist within the smart contracts database. So it means this refund amount, since it is still part of the total supply, we'll have to remove it from the total supply to create some balance. Okay. So again, this is going to basically bring in some scarcity of the token to again deal with the demand and supply of it. So right here, we basically subtracting the refund amount from the total supply and logging or giving this message: the account of the sender was deleted or does not exist. And then after that, we emit a fungible token ban event. Okay. Then from there, we return the amount and the refund, amount. So up here, we returned amount minus minus the refund amount and 0. So in this case, there was no refund, or rather it was handled within our smart contract. So it was actually credited back to the sender. But in this case, since it was burnt, we specify that within the tuple that we're trying to return over there. So that is basically how we go about that. And if the receiver balance was, so after that, we're going to, let me have a look. We're going to return a tuple. So this is also a return value, or this is going to invoke return of this value at this point. That is if anything went wrong within these if statements. Then yeah, here we're implementing the fungible token resolver method. Like I said, FT resolve transfer. And so this was internal FT transfer. So this is actually where the gist happens. However, what we used the FT resolve transfer function that I talked about in our callback is implemented down here. And it is actually making use of the internal FT resolve transfer we just talked about. So that is basically what's happening over there. And that is actually it with the co-implementation of a fungible token smart contract. Then something else we looked at yesterday was the metadata, right? So right here, we have a metadata. We have this metadata structure or standard that we need to use. So there's this FT metadata spec, and that string is given to you. FT. You can remember this from our previous illustration. That is in our session yesterday. And again, we're going to see where this string is going to be featured. Then right here, we have all data that is required, that you're required to provide as the metadata to your fungible token. So again, the spec, the specification. So this specification actually should take this constant. Then you can give a name to your fungible token. You can give a symbol to your fungible token, provide an icon string or an icon to your fungible token. If this information is going to be available in an external blockchain storage solution, then you have to provide that reference here and the reference hash. So in this case, the hash of that document. Then you also need to specify the decimal precision of your smart contract tokens. Okay, so that is basically that. Then right here, we're implementing fungible token metadata provider trait. So again, that should be provided somewhere. So the fungible token, this trait is going to, what I've just highlighted, is going to expect a method named FT metadata. So whatever structure that is going to implement this trait must implement or declare this method. So our fungible token, we have the fungible token metadata right here, and we're given a function, basically implementing a function to assert if it is valid. So this one is basically going to require that the spec be equal to the constant provided up here again, guys. Then it's also going to expect self.reference to be available. If this is available, then should be equal to, okay, in this case, if we are going to have a reference value, so if sum is basically going to check if a value exists. Okay, so don't confuse this with if reference is equal to reference hash, because they are never going to be equal in any case. So this is basically checking if some value exists, in which case it's going to be true. Then these other reference hash must exist. And again, I really hope you remember while I was talking of if these reference values available, then the reference hash must be available as well. So that is basically what is being checked in line 27. Then in line 28, we are basically doing in this case, reference hash, and you're requiring, so this is basically checking the validity of that hash. Again, I guess for security purposes. Yeah, so that is basically what's happening there. Let's now move up back to the main. So in this case, our lib.rs file. I don't understand why these errors are coming here. Or something is wrong with my cargo Just okay. That's just fine. Are you guys able to see anywhere where these errors are coming from? Maybe we'll look at that later. Let me first of all go through the smart contract itself. Now, look at this. We have data image SVG near icon. So these are the near icon, the near token icon. So there's this data. It's an SVG string, basically, crafting that near token icon. So this is basically the value we're going to use as our icon in our metadata reference. Now we have our main contract structure. Maybe if I can take us through that first. So right here we are having the token object taking the fungible token shape or type. Then you have the metadata. This is going to be stored in a lazy option. Again, these are a persistent storage solution within the near blockchain. And this will only be called if required. If not, it will never be loaded into our memory. So again, that is it's economical, if I may put it. So this is basically going to take the shape or the type of a fungible token metadata. So these are the two instance variables within a structure. Mark you, this is out. So don't forget that. Then we're implementing some method within our contract. And the very first one is going to help us initialize smart contract. And that is the new method. We realize it's taking the init macro. So again, this is only going to be called once. Once it is called, you can't call it again. So it is first of all going to check if state exists. So again, if it has been initialized or not. Okay. If it has been initialized, then it will resolve with this statement, or it will panic with its string. If it exists, it will be true. Then right here, we are negating it to get the false value for us to be able to panic with this string. Then right here, we are checking or we are setting if the metadata is actually valid. So again, the function we saw in our metadata structure. Then right here, we are initializing our smart contract object. So we are doing self and providing the instance variable, or rather initializing the instance variable. So in this case, we are doing Fungible token.new. So double full colon new. Then you're providing a prefix to this. So again, to uniquely identify our data structure. Then we also have the metadata as a lazy option. And that is how we initialize that. And we give it some value. And this value is going to be whatever object you're going to pass as our metadata. Again, you're going to see how that is taken care of. So that is basically going to assign this contract object to this variable, this. Then take keynote in line 71 and line 72 and line 73, because they really hold. This is how we're going to make use of the methods we've just gone through previously in the fungible token standards. So again, for us to be able to link this structure to whatever standards that NIA has already availed to us, we're going to make use of the internal register account of these tokens. So in this case, the fungible token standard. Okay, so we're just going to do this token internal register account, passing down the owner ID. So I guess this is going to be the initial owner. So this should be added to the account's data structure we saw. Then this token.internal deposit, passing in the owner and the total supply. So again, this is basically going to assign total supply to this owner wallet address. And again, we are passing the owner as account ID to this new function. So don't be worried where that is coming from. Then we're going to register some events right here. So if there's going to be a mint, any mint event within our smart contract, we're going to listen for that and then basically meet it, right? So that is basically what's happening here. So over here, we pass in the owner ID, the amount, that is the total supply, of course, and the memo. I guess this should be optional. Then we basically make that. And then we return with the these object. So this is basically what is going to hold the state of our smart contract. So that was really important for the initialization of this. Now up here, the new default meta is basically going to help us, bootstrap these other than providing all these from our front end or our CLI. Again, this is just for demo purposes, okay? If you're going to do something that is going to face a real market, then you may be careful providing this, or you may really be careful on how you're going to feature this within the smart contract. So our new function, again, what we just went through down here, is going to expect owner ID, total supply. So owner ID and total supply. And then it is also going to need the metadata. So in this case, here is how we've captured the metadata. So that fungible token metadata structure, we're passing in the required fields. So in this case, the spec, and again, like I said, FT metadata spec to string. The name, in this case, I've named it Kenya shillings coin. Let's change this name and give it something else like African coin. I think I love that. Then we can as well give something else over here. Okay, what symbol should this take? Maybe someone can suggest in the chat. What symbol should we give our coin? I'm waiting for any value that is going to pop up first. In 1, 2, 3, AFC. Thank you. So let's go with AFC. Then you realize over here, we are passing the icon using the value we just saw above over there. So we give him that to string. So that is basically going to provide a an image representation of the image icon to our fungible token. So that again is going to be the NIA's token SVG icon. Okay. So if you can come up with our own for our AFC token, that would really be great. So it's going to take the decimal precision, as you can see, is going to be 24. So I guess this is NIA's standard decimal precision as well. And right here, we don't have any reference, or we don't have any external reference file that describes our metadata. Okay, so that's why we have none and none over there. If we had this, then we must provide this. Please take note of that. Then down here, I have, I actually wanted to draw your attention to this, like 91 and 92, but I'm coming to that. So right here, these methods, these are the methods that are going to be invoked in case of the events we just saw. So in case of the fungible token mint event, fungible token ban event, fungible token transfer event, okay? So the very first method is on account close. So this one is going to be invoked if any account is going to be closed. So someone is going to unregister from our smart contract. So if it is going to detect that a wallet address has unregistered, then this one is going to be basically invoked, and it's basically going to log closed this account ID with this balance. So basically a message. Then if any token is going to be banned, So like the scenario we just covered initially. Sorry, guys. The scenario we just covered initially, where someone is trying to transfer tokens to an existing wallet address. So to a wallet address that that does not exist within the smart contracts database. So in that case, some tokens are going to be burnt, right? And the method that is going to be invoked. So if you wanted to handle that information in some other way, then this is where you can basically achieve that. So for now, we're just logging out account, passing in the account ID, burnt this amount. Okay. Again, you can play around with this and tweak it to your own preference. Then out of that block, so out of our implementation block, okay, so that was our implementation of block. Outside it, we are using the near contract standards. So I think I confused this while I was explaining something on line 71 and 72. This is the line that is going to help us make use of the methods I just took us through on the fungible token standards and the fungible token metadata. So again, here we are pulling in the near contracts, the near contract standards module. And from that, we are invoking this macro, the implement fungible token core. So this is going to implement all the core standards. So we're basically passing in our contract structure, our token, so in this case, the token object, which is an instance variable within our contract structure, and the on tokens burnt method of our contracts structure right here. Then over here, we're also doing, right here, we're doing the near contract standards module, and we are invoking this macro. So this is going to help us implement all the storage staking methods or functionality to our smart contract so that people stake some tokens for storage purposes of the information against their also the accounts information. So again, here we just pass the contract structure, the token object in our contract instance variable, and the on account clause. That is the method that we just gone through over there. Then right here we are doing fungible token metadata provider. So we are implementing this trait. This is a trait in our metadata file. So right here. So we basically be implementing this method like I explained earlier. So we are implementing it and we are saying it is going to return some data that is going to take this type. And that is going to be self.metadata.get. So again, this is basically going to get our metadata information of object that we passed in. And then from there, it's just a series of tests. Okay. So you can always go through that on your own. Now, my errors are still persisting. So I'll see if we can build this. So again, I'll just head on to my build script. So first of all, I have to grant some permission to this machine to do all that. We should be familiar with this up to now. So I'm simply going to grant every script file permission in that case. Then I'm going to invoke scripts. We need to provide this path well, then build. .sh. Let's see if that is going to actually build a smart contract. If it all goes successfully, then you should be able to go. Otherwise, if the errors persist, then we'll have to find another way. So from my end, it seems everything went well, but still the errors are there within my source code. So we'll just go ahead and try if we can deploy this and basically make some call functions on it, right? Now, I have I have this address that I'm using. So ft.lumala.testnet. And then I have, so right here, you are basically deleting this account, then we're recreating it, and then we deploy our smart contract. Okay. So let me just counter check my cargo.to file and see if the naming is right. So that is FT. Okay, so that's awesome. You should be able to find it under the resource folder. So let's just go ahead and see if this is going to run. That should be deployed. Let's hope this deploys successfully. So first of all, it will delete that account here. Yeah, it's done deploying. I'll do the upgrade. Let me just do the upgrade somewhere else. Now we're going to see if we can make some calls, okay, to our smart contract. Let's see if we can make some call to our smart contract. And I head on to my initialization. Like I said, we have to initialize our smart contract first before we can actually perform any other operation on it. Now, to do that, or rather to achieve that, I'm going to do near call. And this is the wallet address or the account ID where we deployed our smart contract. And I'm going to invoke the new default metadata function that we have availed within our smart contract, passing in these parameters. So again, the owner ID as that, total supply as that, okay? Then we're going to sign this. So we're going to sign this transaction, and that is basically how we go about that. So let's try running this and see if this is actually going to work. If it fails, then it's due to the errors within our, yeah, so that just went successful. You realize it returned with an empty screen. So that was successful. So we've just initialized our fungible token smart contract. Now there's something really interesting that I'll be showing us as we proceed, how this is going to be reflected in our dashboard, our near wallet dashboard, okay? So now that we've initialized our smart contract, let's see, okay, this was buy, and this was great. So we can use this file first. So let's make use of this file first. So we're going to try to check the balance of this wallet address. So from our knowledge, we very well know that this wallet address is not yet registered in our smart contract. And so by running this, it should return or resolve with a 0. Okay, because this wallet address is still not registered within our smart contract. So let's just see if that is actually the case. Great. So you realize it simply returned or resolved with a 0. So I'll just comment that out because we've not registered that account ID within our wallet address. Then just out of curiosity, I'm going to try and transfer. So right here, I'm going to try and transfer some tokens from this account, in this case, whoever is signing this transaction. Now this guy is already registered, so I'll just try and I'll use, yeah, so this wallet address has not been registered, so I'll just try and use this. So I'm doing this way we deployed our smart contract. I'm doing a call to this function, and I'm passing these parameters of some transferring to this wallet address, and this is the amount. Again, this is in York to near, so you can convert that to near to get the actual value. Then I'm signing this transaction using this, and I'm passing this amount of near token. So this is actually 1 York to near, guys. So the decimal value should not scare you. That is just 1 octonier because that is what was required while doing, as we saw, I mean, while going through the code. So let me try and do that. This one should fail because the account is still not registered. Awesome. So as you can see, it failed. So it panicked by saying the account lumala.testnet is not yet registered. In other words, we have to register it first before we can make any use of it. Okay. So I'll just comment that out for now. Now I want us to register it. So we first of all are going to register that account. I think we do that by invoking this. So again, someone was asking about storage staking. So while registering, you realize that there's this amount of NIA tokens we are attaching to this call. Now, this is the amount that is going to be used for storage, or the amount that is going to be staked for storage of the information against our account, and in this case, the YTO.testnet account. Okay, or we can as well use Lumala. So these are wallet addresses that I've already logged into from my near CLI. So let's first register Lumala. So just clear my command line and run this again. So if the register is successful, awesome. So you realize that the total amount of NIA tokens, in this case in Octoneer we've staked, is this, and they're available. So there's no token available for us to use. All of it has been staked. Okay, so that is basically the object that was returned to us. So in that case, the registration was successful. So I can just comment out that, and now try. Okay, let's also register YTO, because these are the two accounts we're basically going to use to invoke the transaction. So let us also just register the YTO.testnet as well. Great, so that was registered as well. Now I can clear my terminal. So we have the two wallet addresses that we're going to make use of. Now I'm going to try to do what? To transfer. No, before we transfer, because we still don't have any NIA tokens within the wallet addresses we just registered. And so we have to mint some tokens to these wallet addresses. And how do we do that? Is the transfer function. So again, in our initialization, this is the account we used. So let's make use of this. So we're going to transfer, and the account we're going to transfer from is our contracts account, in this case, ft.lumala.testnet, and we're going to transfer this amount to YTO.testnet. Okay, so let's just have that run. If all goes well, yeah, it returned with an empty string, so everything went well. It means the transfer was successful. So now that we have some tokens within our YTO.testnet account, okay, let's try and check the balance and actually see if we actually have that amount within our wallet address. So we achieve that using line 6 command. And again, we are passing YTO.testnet as the wallet address. So if we try run that, you realize it returns with this value. So this is the amount of tokens that YTO.testnet wallet address apparently has as the balance. Now, what if we wanted to transfer this value to lumala.testnet? Okay. So let's just transfer some value. So in this case, the receiver is going to be lumala.testnet. So let me just clear my command, sorry, my terminal. So these should transfer all these tokens to Lumala. Again, it resolved with an empty string. And now if we try to check the balance of yto.testnet wallet address, we ought to get 0, because in that case, we transferred almost everything. So YTO, did we make the right call? So this was the receiver. Oh no. So we did make the right call. So whatever we just did is we transferred some tokens from the owner to Lumala, the testnet wallet address. But I wanted us to transfer it from YTO.testnet. So let us just have that repeated for me to demonstrate this. Yeah. Yeah, so that was successful. Now, if I try to check the balance now, we now try to check the balance, you realize it is 0. Okay. So this is actually 0, as you can see. So you realize that YTO account balance is now 0. Okay. So we transferred all the tokens to Lumala.testnet, and let's just confirm that by checking Lumala's balance. So if we try to check Lumala's balance, you realize we now have 2 nears. So this is actually 2 near tokens over here. Okay. Now I'm going to try to transfer some tokens, and maybe before I do that, let's also check the total supply. Okay. So we're going to invoke total supply method of our contracts, of our fungible token smart contract. Now these should be somewhere. Where is that? Should be actually FT total supply, if I'm not wrong. So if I can just have these copied somewhere down here, then just comment that out for now. FT total supply. Guys, I hope that is the right spelling for supply. This should be a view function. So let's try calling that. I really hope.
Supply is double P.
Oh, it should be double P. Okay. Thank you. So let's try and call that. Awesome. So you realize that we have this amount of linear tokens as our total supply. So again, how much is this? Let me see. So that is 10 near. That is 10 near. Okay. Now I'm going to try to do what? To transfer tokens to a wallet address that does not exist within this smart contract. And let's see what's going to be printed out. So we can pass something here like Alan, of course, .testnet. So Alan has not yet, and Alan, I hope you've not you've not yet registered to our smart contract yet. So this account should not be found within our smart contract. So I'm basically going to try and transfer some 1 near. Yeah, that is 1 near. So 1 near token to this an existing wallet address. So these should actually burn some near tokens so that when next we check for these total supply, we should get a different value. Okay, let's just have a look at these and see what's going to happen. So right here, oh, this one failed. The smart contract, oh, it doesn't have enough balance because we used YTO, and I intended to use Lumala because Lumala has enough balance for this. So let's just repeat that. Great. Now let's see the panic. The account alanocoth.testnet is not registered. Okay. And if I can get that string that it panicked with, it's quite a bunch of string right here. Quite a bunch. But let's try and now check. Let's check the total supply. Oh, it rolled back. So this one just rolled back. It didn't burn. Oh, the burn happened when we do the cross contract call, guys. So if we are trying to send it to a wallet address that has a smart contract deployed in it, I think that is when the burn occurred. Maybe you can just confirm that as well. So fungible token right there. Then we can find FT burn. Sorry, FT burn right here. So FT burn was implemented in this method, internal FT resolve. You realize? So in this case, if you're trying to transfer, if you're trying to do a transfer call method, that is when it happens. But in this case, it's basically rolled back, and so the transaction never took place in essence. Okay, so it really never occurred. That is basically what it means. So guys, that is basically it about the smart contract. But wait, let's head on to our dashboard. Okay, so let's head on to, let me just head on to my browser. There's something interesting I want to show us right here. I hope it's that. So right here, so we are here in the browser, right? Now let me head on to my wallet.testnet dashboard. And I'm going to open the YTO and Lumala wallet addresses that we've been making use of for us to be able to actually see this. So my YTO.testnet is right there. Okay. Then maybe if we can give these a refresh. It doesn't seem to have been displayed here. Let me have a look at Lumala. Lumala, the testnet. Great. So Lumala, now have a look at these guys. So our token has been listed in our dashboard, okay? The near wallet dashboard. And in this case, the full name of our token was African coin. And this is the icon image we gave to our token. So it was basically the NIA's token icon. We've not listed it. We've not listed it yet to any marketplace. So I guess that's why the price is unavailable over there. But then Lumala has 2 AFC. And again, if you can remember, AFC was the symbol we gave to our token, to our fungible token. Okay. So if I can head back, let's just head back to our right here. So at this point, we're going to transfer, and we're going to transfer from ft.lumala. We're going to transfer this to lumala.testnet, and we're going to transfer exactly one token or one AFC token. So let me just have this cleared out, and let's call that. And let's see if it is going to be successful. And great, that was successful. So if we head back to our browser, then this value should change to 3. Let's just give it a hard reload and see if that was actually the case. Great. So you realize after transferring 3 tokens, in this case, 3 AFC tokens to our lumala.testnet, it was actually listed right here. Okay. So guys, that is basically it about the fungible token. I don't know if there's any question from anyone or any clarity you need. But basically, that is how you do a fungible token smart contract with all the standards that have been availed to you by NIA.
Tomorrow is the last class.
Yeah, tomorrow is going to be our last class.
Wanted to ask, like you say, like within the blockchain space, security is such a big issue.
Yeah.
There are a lot of breaches and attacks. So I wanted to ask about when it comes to NIA, what are the recommended best practices when coding smart contracts so that you get to address the security aspect of it. Like, for example, when it comes to Ethereum, there's this organization called Consensus that has the recommended best practices in which you're supposed to follow when developing smart contracts so that you can try prevent breaches and attacks. So I wanted to ask if there's something the same that exists in the NIA protocol. Okay.
Oh, sorry. I was actually talking while muted. So there's that link I've shared in the chat. I don't know if you've seen it.
Yep.
Yeah, so you can use that to learn more about the best practices that you can actually adhere to as a developer. But still, NIA avails, it was actually, this was something that was availed recently. Let me just find a link to it very fast. Come on. Okay. So if you've done a smart contract, but you'd want an audit. So basically to establish all that you're, all that you're talking about. So that is the link that I was talking about. If you've done your smart contract and you'd want some audits to it by some experts. Now, there's another course in the NIA blockchain called that deals with security, purposely security. We're yet to feature it. We still don't feature that, but we're yet to feature it. So for now, those are the 2 solutions I know of that can help you as a developer to establish security and best practices. Yes?
Okay, thank you for that. I'd like to pursue that as well.
Yeah, so we'll be giving updates on that once it is ready. Just be on the look, right?
Okay, sure.
Yeah.